Hey folks, welcome to our lesson today. We are going to learn and go over the surface area and volume of spheres. Pretty exciting stuff. We have two formulas that we will use today. Obviously, we're going to talk about surface area and volume. Normally, if we had class, I would bring in cuties, like those little mandarin oranges for everybody, because there's a little demonstration that helps us kind of remember why the surface area formula is what it is. But instead, we will watch this YouTube clip. But if you have a mandarin orange at home that you want to follow along and do it with this person, or just enjoy it and eat it while you watch, please feel free. But okay, so the gist. I will kind of talk over this. I sped it up because we don't need to watch the whole thing. We'll just kind of get the idea of it. But right now, obviously the mandarin orange represents a sphere, right? And what person just did there was draw out its its circumference, okay? So now they are tracing that circumference they traced out from the mandarin orange and are just making copies of it. So that's what's happening right now. They're just making copies of that circumference. Okay, so let them finish up here. I didn't realize you could speed up things on YouTube. We are watching this twice as fast, so it's kind of crazy. Okay, so now you're peeling the orange. And they're peeling it, and you're filling the circles with the peel. So right now I would ask you in class, you guys, what does the peel represent on our sphere? The surface area. Yes, good thought. It does. So right now we're trying to figure out how many circles does our peel fill. So we're breaking it up into all these different little pieces so we can cover our circles. Let's see how many we get here. And we find that the peel covers 4 circles. And obviously this isn't perfect because when you trace it out, you're not being very accurate. I mean, you're trying to be, but it's not going to be... okay, we don't need to go this anymore. I gotta pause this. I don't know what's happening. We'll just exit out. Okay, there we go. So we just found that. Hey, my brain. There we go. Okay, back to this. So the video just showed us that the peel of our orange, which we said represents the surface area, filled up 4 of those circles. Well, let's think about this, folks. We know that one circle's formula is pi r squared. And if I just filled 4 of them, put a little 4 out in front and bingo, done. So that's it. Surface area of a sphere is 4 pi r squared. So again, if you're taking your own notes or taking my notes, whatever, jot that down. I don't have a fun video or demonstration to show you for volume, but our formula is 4/3 pi r cubed. You could look on YouTube. There are videos that show that it's just not quite as simplistic as this one. I think it is more confuses people more than it actually helps. But again, we'll plug into the formula. You guys like formulas. You just like to crunch numbers out. And we're good at that. Okay, and one last thing we have to talk about before we get into actually calculating the surface area and volume is something called a great circle. So the main takeaway of a great circle is that it's what cuts a circle in half. So this is what creates the 2 hemispheres, or the big thing you need to know is that it goes through the center. So like this right here is a great circle because it goes through my center. Whereas you guys see these little guys over here, these are not great circles. Again, the biggest thing is if they're telling you it's a great circle, that means you have half. Oh boy, that's supposed to be, well, this, good thing you can't see that, never mind. It just tells you that you have half a sphere. So if you have a great circle, you have a hemisphere, okay? That's the big idea here. Whereas if you're not given a great circle, you would have some random fraction missing from your sphere. Okay, this seems really confusing. It's not. Let's just try these out and see how it goes, okay? So it says, find the surface area. So again, remember our formula is 4 pi r squared. And now, folks, it's just plugging in, okay? So our radius would be half of 22, so 11. We're going to plug in 11 for r and go from there. And again, this is calculator work. You type this in however you want. I'm going to break it down just for anyone who kind of isn't quite sure. So 11 squared is 121. 4 times 121 is 484. And then 484 times pi is approximately 1,520.5, what is our unit, feet squared. That's it. All we did, plugged in our radius and crunched out the numbers to get our answer. Okay. Now let's try finding the surface area of a hemisphere. So this is half a sphere. So it starts off the same, but instead of doing it all the way like this guy, in the end we're going to have to divide this by 2 because it's only half of that, okay? So let's start with plugging in our formula. So pi r, our r is 2.8 squared. Now let's simplify this a bit. 2.8 squared. We're going to have 4 pi times 7.84. Multiply that by 4. 31.36 pi. Multiply by pi. We have 98.52. Okay, now remember that would be if we had a full sphere, but we don't. So I have to divide this guy by 2. And we get 49.26-ish, approximately. We're done, right? Like, all we had to do was divide it by 2. I wish it was always that easy, but it's not this time. Because we just kind of found, like, the dome part. But remember, surface area is all of the surfaces, like the tops, the bottoms, all over. And what we haven't accounted for yet is this bottom circle. This bottom down here, we haven't accounted for that area. So now we have to find the area of that bottom circle and add it to the dome that we just found, okay? So let's find that bottom circle area. So it's just going to be pi r squared. Plug in our radius of 2.8. We said 2.8 squared was 7.84. Multiply by pi. 7.84 times pi, we get approximately 24.63. So now our total surface area, we got to add these two together. So 49.26 plus 24.63. 49.26 plus 24.63 is approximately 73.9. What are we in? Centimeters squared. So again, what we did there, found the surface area of a sphere, divided it by 2 because it's only half, but then we didn't account for this bottom circle, that's the base of that dome, so we have to find its area. And then we add those together to get our total surface area. Okay, let's try this next one. So it says, find the surface area of a hemisphere if the circumference of the great circle is 36 pi centimeters. Okay, so this is kind of There's kind of a lot going on here, because it's like, where do I start? What do they give us? It's just kind of a lot. So our end goal is to find the area of this hemisphere, okay? So that's what we just did in the last problem. But they don't give us our radius, so we first have to use the circumference of the great circle to work backwards to find our r. So let's start there. So now you're thinking, what is the formula for the circumference of a circle? If you don't remember, there's a quick little song. Twinkle, twinkle, little star, circumference is 2 pi r. Okay, so we know 2 pi r is equal to 36, because that's its circumference. Now we need to get r by itself. Well, lucky for us, look, I can divide both sides by pi, so we can say c to pi. So now we have 2r equals 36. Get r by itself, and we find that r is 18. Okay, how are we feeling? So now from here, it's kind of like the problem we just did. So let's first find the circumference. So I can try draw this, you guys. It's going to be terrible. Okay, that is my really bad hemisphere. But we just found our radius to be 18. So now let's find its surface area. So we're going to have 4 pi 18 squared. Let's square 18. And we get 324 times 4, 1296 times pi. And we get 4071.5. Now remember, we have to divide it by 2 because it's not a full sphere, it's only half of one. So divide by 2 and we get 2035.8-ish, approximately. We definitely did some approximating here. But now remember, we have this bottom circle that is unaccounted for down here that we haven't found the area of. So now we need to find that area of that bottom circle, which is just pi r squared. Plug in our 18. We said that 18 squared was 324. So I have to take 324 times pi, which is approximately 1017.9. And now to find our total surface area, we add up the dome of our sphere and its base area. So total, add these bad boys up and we'll see what we get. I'm running out of space. Why? Okay, let's see here. 0.8 plus 17.9. I get about-ish, because again, we approximated a bit here. 3060.9. And depending on when you round or how you round, or if you use 3.14, your answers might be kind of far off, because in my notes that I have from previous years, I didn't multiply by pi till the very end, and my answers are 7 numbers apart. So that just tells you how big rounding plays into effect of your final answer, okay? So just ballpark, be close to this, and we are golden, all right? I feel like we're going fast. Are we going too fast? I wish I could see your face. Okay, we have one left. One left in this little section here. So it says, find the volume of a sphere if the area of the great circle is approximately 249 square millimeters. Okay, let's break this down a bit here. So our volume formula is 4/3 pi r cubed. So really what's important here is, well, we need to know our radius to find the volume of any sphere, right? But if I look here, am I given my radius anywhere in this problem? Well, not directly, but we can find it because they tell us the area of the great circle is 249 square millimeters. So let's work backwards again to find our radius. So area of a circle is just pi r squared. And we know ours is equal to 249. So now let's find r. So we're going to have 249 divided by pi, because we want to get r by itself. So we have r squared equals 79.26-ish. Again, we're rounding. It's okay. Take the square root. And we find it to be about 8.9 is our r. Okay, now from here, since we know our r, let's plug it in to our formula. So our volume is 4/3 pi. We said our radius is 8.9 cubed. Again, there's multiple ways to simplify this. I'm going to do what works in my brain. You do you. You can type this whole thing in your calculator if you want. I just find that I make more mistakes when I try to do that. So I'm just going to break it up piece by piece. I'm first going to cube 8.9. So remember, that's just taking it times itself 3 times. So 8.9 to the power of 3 is 700, well, this is round to 705, so we're going to do that. Okay? And now this is what I like to do. I'm going to take 4 times 705, so 4 times 705, and I'm going to get 2820 divided by 3 times pi. Running out of space. Okay. Now I'm going to take 2820 divided by 3, and I'm going to get 940. And now I can multiply it by pi. And we should get ballpark. Again, there's a lot of rounding in this problem, so just be ballpark close to around 2,953.1 millimeters. Yes, we are millimeters cubed. Again, just to show you, it's okay if you're not exactly right, because when I did this, whenever year I did my key, I got 2955. So we're not the exact same, okay? Again, so it just comes down to when you rounded, when you multiplied by pi, and if you use 3.14 instead of the pi button, there's just so many different factors. It's just crazy. Anyways, thanks for tuning in. Please come to the Zooms if you're having any issues. Let me know, guys. I'm here for you as always. Be united, live the tradition, kindness week, all of those things. We'll talk soon.